All right, let's talk about changing phases and what happens when we change phases. You can actually do two different things to change the phase of a substance. You can change the temperature, which is what you guys are probably most familiar with, but you can also change the pressure. If we change the pressure, what that does is that either forces the molecules closer together or it allows them to drift apart. During the phase change, the temperature and kinetic energy are held constant, meaning they don't change. Potential energy, though, is changing during a phase change. So again, temperature and kinetic energy don't change. So when water is boiling, it boils at 100 degrees Celsius and it will stay 100 degrees Celsius until all of the water has turned to vapor. When water freezes, it freezes at 0 degrees Celsius and it will remain at 0 degrees Celsius until all the water has turned to solid. There are two phase changes occurring at the same time, so there's some equilibrium happening. So while our water is freezing, the water is kind of going back and forth between solid and liquid until it all ends up being solid. So there's the process of freezing and melting occurring at 0 degrees Celsius, which is why water melts at 0 degrees Celsius and freezes at 0 degrees Celsius. It just is the potential energy increasing or decreasing, which tells us which direction we will ultimately end up. There is a video link on the Canvas page, so make sure you watch that video. That's what this is right here. And it's going to define the word temperature for you, so make sure you write that down in your notes, and then also what room temperature is considered. Now remember, we do Celsius, not Fahrenheit, so it might not be what you're expecting it to be. One of the ways that we graph this information is by looking at a heating curve. And yes, you're going to want to copy the heating curve into your notes, and then we're going to label the different parts. Down here at the bottom where we have the coldest temperatures, that's where we have our solid. So this diagonal right here represents the solid. Now there's 1, 2, 3 diagonals. 3 diagonals represent the three phases. Okay, so in the middle we have our liquid phase, and then up here at the highest temperature would be our gas phase. The two plateaus then represent the phase change, going from solid to liquid. So what is the phase change called that goes from solid to liquid? Why, that's melting. And we can read this graph and figure out the melting point. Anytime you hear the word point, that means it's talking about a specific temperature. So the melting point would be this line right here, and we would just trace it over to our y-axis, and we see that it is 0 degrees Celsius. Up here where we have our second plateau, going from liquid to gas is called boiling or vaporization or evaporation, depending on where the gas originates in the liquid. And if we trace this straight across, we can see that the boiling point is 100. So because the melting point is 0 and the boiling point is 100, I know that this phase or heating curve is for water, because water is the only one that would have those two temperatures. Other substances are going to melt and boil at different temperatures, which is why you just have to trace those plateaus over to the y-axis to determine what the boiling and melting points are. Okay, notice that the lengths are also different. So the melting plateau is smaller than the boiling plateau. Why is that? What's happening? Well, it takes a lot more energy, a lot more potential energy to separate the liquid into the gas phase than it does to go from melting or from the solid to the liquid. All right, so here's our cooling curve, and what I would like you to do is copy it down into your notes and then see, I'm trying to move myself out of the way here, and then see if you can label what these points are. All right, let's see how you did. So again, higher temperature is the gas, middle temperature is the liquid, colder temperature is the solid. And then the plateaus, gas to liquid is condensation, and liquid to solid is freezing. And if we wanted to know at what temperature it condenses, or the condensation point, we could just trace that line over to the y-axis and get the temperature. Same with the freezing point. We can just trace that line over and look at the temperature.